Okay, in this lesson we're going to talk about graphing polynomial functions. Specifically, we're going to talk about end behavior based off of degrees and leading coefficients. We're going to talk about graphing using the zeros, and we're going to talk about graphing using characteristics. So you're not just using your graphing calculator to graph it for you today, because we're not even doing a precise graph as your graphing calculator will. So don't worry about your graphing calculator. We're just going to learn about some features of this graph, and we're going to draw just a really general graph, not super specific. Okay, so first remember that polynomial functions, we have lots of different types based off of the degree. So the first polynomial function that you're probably familiar with would be a linear function. And this is just really general. It's just showing that that power, that largest degree, is 1. And then we have quadratic, which we've done lots of, some cubic, and then some quartic. So these are based off of the degree. Now we are going to be using the degree and the leading coefficient to be able to determine the end behavior of the graph. So what is happening at the ends of the graph? So as far as leading coefficient goes, that's the leading coefficient for the polynomial function when it's written in standard form. So if all of these are written in standard form, meaning their exponents descend, this is really an x to the 0, their exponents descend. So if you notice that here as well, okay, so the leading coefficient is the first coefficient that you see when it's written in standard form. So we use the leading coefficient and the degree to be able to tell us how the graph is going to look. Now, if you remember from previous lessons, when we talked about quadratic, we know that a quadratic graph looks something like this. Now, that's only when the leading coefficient is positive. Okay, that's what opens it upwards. Okay, and then the other thing that we know about the graph is how many times it crosses that x-axis. And that also has to deal with the degree. This degree is an even number, meaning I can cross that x-axis twice, so it's going to have the same end behavior on the left and on the right. Now we're going to use this idea to be able to expand our knowledge to quartic and cubic and quintic and all that kind of stuff. Okay. Now, the other thing that we didn't really talk about before, but I want to mention, this degree, the fact that it's even, tells me how many curves I have in this graph. And we actually call these, well, yeah, we'll just call them curves. So you'll have the degree minus 1 number of curves in your function. So if I have a quadratic function, I'm going to have 1 curve in that graph. But if I have a cubic function, I'm going to have 3 curves. So if I draw this graph, you go 1, 2. Do you see that? 1, 2. But then it ends up being that I have 3 zeros. So you kind of see where I'm getting at. You can tell where the graph is, how the graph is going to look based off of your degree and your curves, your zeros, all that kind of stuff. Okay, so end behavior. What is end behavior? So it says the end behavior of a function is the behavior of the graph as x approaches positive infinity or negative infinity. For a polynomial function, the end behavior is determined by the degree and the sign of the leading coefficient. So what have we just talked about? I'm going to sneeze. Whew, okay. So the end behavior of the graph is literally the behavior of the graph at its ends. So what is happening at the very ends of the graph? Now for the right side of the graph, that's as x approaches positive infinity. So over here, as x approaches positive infinity. But on the left side of the graph, so if you think about those the negative half of that x axis, it says x approaches negative infinity. As x approaches negative infinity. And we want to see what the function is doing. Okay, so when I look at, let's do this quadratic, okay, if we go to the right side, I always just like to start with the right. The function is going upwards, meaning it's also approaching positive infinity. And on the left side of the graph, as x approaches negative infinity, the function also approaches positive infinity. It's going up. But on this cubic graph, when we start with the positives, the function's still going up, so it's approaching positive infinity. And on the left side of the graph, it's going down, so the function is approaching negative infinity. And that's really kind of the gist of it. We're going to talk about it more specifically in just a minute. Now you could write this down, or I've got this that might be more clear for you to see, but I wanted you to get an idea of it first. So while you're going through this video, remember, take some time, pause it, write down some notes. Don't just simply watch the video, that will not help you. Take some notes so that you can go back to it as you're going through your check your understanding questions. Okay, so end behavior. So this is just something that comes right out of your book, and it just talks about that exact same thing we talked about. Now let's start with the even degrees first. These are like your quadratic or quartic functions or beyond. Because they have that odd number of curves, see how you got 1, 2, 3? That means the two ends end up going in the same direction. 1, 2, 3. It brings them back to that same direction. So they're the same on both ends, which makes it really nice because now I just need to know if it's positive or negative. The positive graph means it opens up, meaning as x approaches positive infinity and as x approaches negative infinity, the function approaches positive infinity on both sides. It's going the same direction upwards. Now it doesn't matter if you write f of x approaches positive infinity as x approaches positive infinity, or if you flip those and put as x approaches positive infinity, the function approaches positive infinity. It doesn't really matter. So just pick away and go for it. Now if it's negative, it's the same, except for now it's opening downwards, meaning on both ends, the positive and negative infinity for x, the function is going down, so it's approaching negative infinity. So this arrow that we're using is representing approaching or approaches. So that's what that arrow means. It's approaching that, meaning it's going in that direction. So the even degrees are pretty simple because they're going in that same direction, whereas the odd degrees are a little different, okay? So the odd degrees, they're opposites because now they have an even number of curves. 1, 2, 1, 2. So they have to go in opposite directions. Now, if it's positive, just know that the graph, when you go from left to right, it's starting from a smaller number and getting bigger and going up. So generally, it's going up over time. Whereas a negative graph is going down over time. That's how I think about it, but you don't have to think about it the same as me. It's just a way to kind of help you. So a positive graph is going up, negative graph is going down. So what that means is, on the positive side, they're both going up. And then on the negative side, they're both going down. But that's only for the positive leading coefficient. And when I do these, I'll draw this little picture to help me write these end behaviors. So for our negative graph, when I'm on that negative side of the x-axis, I'm starting from a higher number and then I'm coming down, but that graph, it continues on forever, so we still say that it is going up, even though when I move left to right, it's going down. What's happening is this continues on, so it's still approaching positive infinity because it's still going up. It still goes on forever. And that can be a little confusing. On the positive side of the x-axis, the graph's going down, and so it shows that it's down. So take some time to write this down, and then we're going to do a couple examples together. Okay, so here is a function. We're going to go ahead and describe the end behavior of this function. So if we look at this degree, I know that it's an even number. It doesn't matter that it's 4. You can write 4 if you want, but really we just need to know if it's even or odd. The leading coefficient is negative, so I know that that graph is opening downwards. So I don't need to draw this actual graph, but I'm just going to draw a general graph because I know what this is going to look like. Okay, it's opening down, it has a degree of 4, so I know it's going to be something like this. Okay, I've got 3 curves, 4 zeros, so I know it's going to look something like this. So now let's describe the end behavior. I always like to start on the right, but it doesn't really matter. So as x approaches positive infinity, that's the right side of the graph, because we're on the positive side of the x-axis, the function is going down, and you're really only looking at this very end. You don't need to start all the way over here, just start at the very end of the graph. So the function is going down, so that means it's approaching negative infinity. On the left side of the graph, so as x approaches negative infinity, the function is still going down. So I know it's approaching negative infinity. And for those types of problems, that's really all you need to do. When we get to graphing, we'll graph this more specifically, and we'll use the end behavior to do this. Okay, here's another one. So here, our degree is an odd number. You can put 3 if you want, but it's up to you. But our leading coefficient is a positive. So if I think about those odd graphs, it's going to be something like this. Okay, so I'm going to draw that a little bit better. I have an exponent of 3, so I know I'm going to have 2 curves in it, and it's going to go up over time. So now let's do that end behavior. Let's start on the right side. Okay, so this is my positive infinity side. And the function is going up, so I know it's going to be approaching positive infinity. On the left side, as x approaches negative infinity, the function is going down, so it's approaching negative infinity. Okay, so we're going to go ahead and stop this video now, and then we'll move into graphing in the next one.